Okay, so today we're going to be looking at using trigonometry to find an angle size. Okay, so we're looking still at your right angle triangles. Right angle triangles. Remembering we've got our hypotenuse there, always opposite the right angle. Now, when we're looking at the angle size, we have to consider where in the triangle it is. So if that's the angle of interest, that's the angle I'm looking for, and that is theta. That's usually what we use for an unknown angle. So that there, theta, is our unknown angle, and we're interested in it. So then I've got my hypotenuse, which is there, always opposite that right angle. Then I have a side that's adjacent to that angle and side opposite to that angle. Opposite to that angle. That's a bit better, isn't it? So we always look at our triangle and label it appropriately. We don't memorize, if it's here, I use this ratio. No, we always approach each question freshly with a fresh set of eyes and look at what we have and what we need to know. So let's do a couple of examples. So let's do a triangle. Okay, right angled. Let's make that 14, 10, and I'm interested in finding out what that angle is. Okay, so here I've got my hypotenuse and my adjacent. Now thinking back to my trigonometric ratios, which we can remember with our mnemonic SOHCAHTOA, I have the adjacent and the hypotenuse, so I'll be using cosine or cos for short. So cos theta equals adjacent over hypotenuse. Then I put in my knowns and unknowns, so if that theta had another pronumeral, I put that in there. 10 over 14. So theta equals the inverse of cos applied to 10 over 14. Now, this is because cos is, a thing we can do. So because we've applied cosine to that theta, I have to undo it with the inverse. Okay, so then we can bring out our calculator. So those of you who have the CAS calculator, here in Year 10, just make sure that it's in degree mode. It's in degree mode. If you are unsure, just look up there to see if it's DEG. If it's RAD, that means it's in radians mode. Radians is another way to measure angles, but you're not going to get to that until Year 11 methods. What I recommend you do is at your home screen on settings, so that's 5, go to handheld setup 3. Oh, sorry, I always get this wrong. Settings, document settings, and see here in angle, change that to degree, and then make that default. Okay, because in Year 11, in Year 10, you're only going to need that degree mode. Okay, So what do I have to do? I have to find the inverse cos of 10 over 14. Right, so we've got here our trig button on our CAS calculator. And you can see there we have all our options. All our trigonomic things we need is just under the one button. So there's our inverse cos. So I can put in our fraction 10 over 14. And then I'm going to do control equal for approximately equal. So that means theta is approximately equal to 44.4 degrees if we're doing it in decimal degrees. Now, here in Year 10, we start to talk about degrees, minutes, seconds. So here I've got it just in degrees. Another way of measuring this decimal part is in minutes and seconds. Now what you need to remember is that degrees, minutes and seconds, well, think about minutes and seconds. How many minutes are there in an hour? 60. How many seconds are there in a minute? 60. So how many minutes are there in a degree? 60. How many seconds are there in a minute? 60. Okay, so there are ways of doing that calculation by hand, and you can look up how to do that. In our calculators though, we've got a number of nice functions in which to do it. So if you look here, I just call it the book, and we've got a whole lot of functions we can use. And if I put in D, that's where I start to get to these functions started with D. Now DD is another one you're going to do. That forces the answer into decimal degrees, so like the answer we have before. And if we go down, if we get to DMS, that forces the answer into degrees, minutes and seconds. Again, that using our approximately equal to. So our answer in degrees, minutes, seconds is 44 degrees, 24 minutes, and 55 seconds. So if we were writing this to the nearest second, it would be to 55 seconds. Now if we're wanting to write this to the nearest minute, I would write that as 44 degrees 25 minutes. Okay, so you probably want to maybe look up a little bit on degrees, minutes, seconds if you're unsure about that. But let's look at the process that I used here. I drew the picture of the situation. I labelled my knowns and unknowns. I used the formula. I figured out which of those ratios I needed to use. I wrote it out. Then I put in my knowns and unknowns. So I'm using the same process as I've even did for Pythagoras' theorem. This is the process you should be going through all the time. Now, so when you're looking at written questions, you're doing the same process. You're reading the question, trying to figure out what the triangle is, drawing that triangle, and then writing out your workings out. Now that was a cosine or cos. Let's see if we can identify some others. Okay, so again, so I've got my theta, Oops. So I've got my theta here. The hypotenuse is a known, and this side here is a known, and that is the opposite side. So again, SOHCAHTOA, that is my sine ratio, opposite over hypotenuse. So sine theta equals 11 over 17. So theta equals inverse sine 11 on 17. Theta equals, so trig inverse sine. Now please note I'm saying sine, not sin. Okay, that is number one. You have to please be pronouncing it correctly. It's sine, not sin. So theta is 40.3 degrees, and if I was writing that as degree minute second, get up my book, degree minute second approximately equal to, that is 40 degrees 19 minutes and closest to 13 seconds. Now, one thing to note, on some of the scientific calculators, they sometimes don't have the double quotation, they just use single, but I hope you can understand it. Okay, and one last one. Okay, and theta. So here we can immediately see, well, we don't have our hypotenuse, so it can't be sine or cos, it must be tan. So theta equals opposite over adjacent. And by the way, adjacent means next to. I'm sorry I didn't say that earlier. Adjacent means next to. So opposite, the 12 is opposite the theta. The 8 is next to the theta. That's how you can think of it. Adjacent means next to. So there we are. Getting my calculator up again. There it is. So inverse tan, putting in my fraction, and approximately equal to, so theta is approximately equal to 56.3 degrees, or in degrees minutes seconds, control equals, oops, are up again, grab that, book, DMS, approximately equal to 56 degrees, 18 minutes and 36 seconds. Okay. Now, always remember, draw the diagram, put in your knowns and unknowns, and then work it out from there. Any questions, put them on the comments or email them in. Thank you.